So there are 5 steps in solving the 4x4 Rubik's Cube. First of all, you need to solve the white center, and then you will solve the yellow center, and then you will solve all the rest of the centers, so green, orange, blue, and red, and then you'll pair up all of the edges, and then eventually you'll have it reduced to a 3x3 Rubik's Cube, so then you can apply your knowledge that you learned to solve the 3x3 onto the 4x4 and solve the 4x4 like a 3x3. Eventually there might be a few parity cases here and there, but we'll talk about that when we get there. We're going to try to reduce the 4x4 into a 3x3 by solving each center, pairing up each edge. As you can see, each edge piece of like a 3x3 contains 2 4x4 edge pieces, and then corners just stay the same. So then we can solve the 4x4 similar to how we solve a 3x3. So this is called the reduction method. And this is also by far the easiest to understand among all the methods out there. So let's get started with the first step, solving the white center. As you can see, the white center is composed of 4 tiny white center pieces. 1, 2, 3, and 4 on the bottom. This is sort of similar to solving the cross on the 3x3, where it's pretty much just all intuitive. You can also view this as solving a face of a 2x2. If you're not familiar with a 2x2, however, I'll just teach this intuitively. So first, we want to get at least one bar together, like that. And then you see that we have 2 remaining white center pieces left. You can intuitively bring up one of these pieces, and then we see we have one last piece. When you have 3 white centers on one face and you have the last white center on the opposite face or the bottom face, you can try to move 2 of these already solved white pieces out of the way, and then make sure to move the white piece you just moved up out of the way as well, so then you can restore these 2 pieces. For the last white piece, we want to put the white piece on the front face with the rest of the pieces solved on the top. And what we will do is, you see this junction between these 2 bars, and that's this piece? We want to move this piece to anywhere on the top face that you see can be replaced with this piece. So that's going to be over here. Because you see, essentially, if we move this piece up, you see that we're going to join a bar with these 2 pieces. So now we have 2 white bars, and we can move this bar out of the way, and we can join the last bar in to form the white center. Let's try one more example. We have 3 solved pieces on top, and we have one last white center. We want to move the junction in these 3 solved pieces to the corresponding spot of this piece on the top face, and that's going to be over here. So we can do a U2, so that when we bring this piece up, we join one of these pieces to form a bar while preserving the second bar, and we can move that out of the way and join it back down. And that completes the white center. Moving on to the yellow center, the principle is the same. However, we just have to make sure that we don't disrupt the white center while solving the yellow center. First, we can move any of the yellow pieces up to the top face, such as that. And then make sure that we have to bring these 2 pieces down to restore the white center that we just disturbed. However, if we bring these 2 pieces down just like that, we're going to move the yellow piece down as well. So we have to move the yellow piece out of the way first and then bring it down. Now we have one piece on the top. So now let's try to move another piece up to the top while forming a bar. So we see that this also needs intuition and will get better with practice. But if we move this piece up to the top, we'll join a bar here, and make sure that because we need to restore this bar, we have to move this bar out of the way and bring that bar down. Here we have a very easy case of having 2 bars already paired up. Now, in order to send this bar to the top, many of us would just move this out of the way and put it to the top. However, now we realize that no matter how we try to turn the top face, we can never restore the bar that we just disrupted back there. So what we do is make sure to align the bar vertically with the bar that you just made. Move that bar up to replace the original bar. Do a U2, and then bring this bar down. So now you see that this center has been restored and this center has been formed. So what happens when you don't have two bars, where you only have one bar made on the top face and you have two more center pieces just randomly, separated here? So what we have to do is try to form another bar in these middle faces. So we can do that by moving this to the left, and you see that when we move this piece over, we form a bar here, and similarly align this bar vertically, up, replace it, and then bring it back down with restoring the white center. Last example. Well, what happens when we have something like this, where two of the centers are both on the same face, but they're not really solved? We haven't formed a bar yet. So what we can do is move one of these centers out to another face, such as that, or even just a simple U prime would do. And then we can pair these two up, like so. And then similarly, align these two bars, move it up, replace, down. And now we have solved the yellow center as well. Next, we are on to the side centers. These centers are the orange, green, the blue, and the red centers. So make sure that you understand the color scheme of a 3x3 Rubik's Cube. I have one right here. So you see that when we have the white on the bottom and the yellow face on top, we see that the color schemes goes orange, green, red, and blue. So make sure to remember that color scheme. If we orientate the white face on the left and the yellow face on the right, you see that we're gonna first solve the orange face, and then the one on top of that would be the green face, and then the red face, and then the blue face. Which means if we have the white face on the left and the yellow face on the right, then we have to solve the orange face, the green face, the red face, and the blue face in that order. If we mix it up, eventually you'll see that some of these corner pieces just don't fit into the cube anymore. So how do we solve these centers then? Well, what I always like to do is start with the orange and then go to the green and then to the red and then to the blue. It's just an easy way for me to memorize the order that the centers have to appear in. Remember that white is on your left. So first, similarly, we have to pair up a bar, and then we can move a third piece in without disrupting that bar, and then we can find the last piece. So we see the pieces here. This is on the left bottom of the 4 squares here. So we want the junction, similar to when we did the white face, we want the junction to be on the left bottom square of these 4 squares, so that when we bring this piece up, we form this bar, and then we can move this bar out of the way to restore these two pieces and form the center. In a similar fashion, we can do that with the green face. Remember that we already have one center solved, the orange center. So now we have to be extra careful about not messing up anything that we've already built. We can try to pair up these two centers, this one and that one, like so, into a bar. However, make sure that realize that we already have a center built here, which means we have to move this bar out of the way so that we can restore this center. And there's one key concept here that you have to remember. No matter how you turn the outer layers, none of the inner layers will be disrupted, which means that no matter how you turn the outer layers, none of your centers, which have been already made, will be disrupted. So here we try to apply the same method. We can try to bring the center down and try to form 3 different centers on the same face. However, we see that no matter how we turn this face, we just can't get this bar up without disrupting the 3 centers that we already formed. And this is the same issue that we ran into when we tried to solve the yellow face. So how do we do this then? Well, we have to make a bar on another face and then join it back down. So how do we do that? Well, using these 2 pieces, we can form a bar like so. However, the orange center that we already made has to be restored, which means we have to move this bar out of the way and restore the center. Now we have 2 green bars. Do you remember what we did to solve that for the yellow face? Well, we aligned them vertically, right? And then we turned to replace the original bar, and then we can move it out of the way, and then we can bring the original bar back. Boom, 2 centers. The last 2 centers are the trickiest because, well, you don't have a lot of room to work with. You already have 4 centers done, and it's really hard to solve the last 2. So the last 2 centers will require 2 bars on each face, and this is going to be the goal. So we should have 1 blue bar and 1 red bar on both of these faces. If we don't, we can simply do this algorithm, R, U prime, R prime. And then you will see that you have 2 bars. So we have to align them vertically, like so. And then now remember that the color scheme goes orange, green, red, and blue. So on this face, we want the red center to be here, which means this bar has to come down here. Well, you can also view that as we're trying to solve this bar into this spot. Remember to align these vertically, and then we can move this up, replace, move it out of the way, and then back down. And now you have these 2 centers solved as well. And there will be no case where you have 1 center solved and another center not solved, because there are only that many centers, and with all the rest of the centers solved, the last center must be solved. So that concludes the centers, and now we're on to edge pairing, and we're done with 3 out of the 5 steps of solving the Rubik's Cube. So you will realize that for every edge, for example, the orange and blue edge, there are 2 smaller edges that can be constructed together to make the larger edge right here. 1 orange and blue smaller edge and another one right here. So how do we conjoin these together? It's fairly simple. We just find the 2 edges, put them adjacent like so, and this will also require some intuition, because if you have something like that, well, no matter how you move the layers, you won't get that piece over. So set these pieces up so that they can be paired like so. And then we can do a slice move here to pair these 2 up. And then we can go to the top layer to find any edge that has not been solved and replace it into this slot. And you see that we just pushed out the edge that we just solved. And then eventually, of course, we have to restore our centers. Now you see that we just paired up 1 edge. And now we can continue. So for example, let's try to find the corresponding edge to this edge, the white and green edge. Well, we see that right here. So how do we pair these up? Well, we can move this to the right, and then we want this edge to be over here. So we can move that in like so. And then now we see that when we slice these 2, we pair these 2 up, and then we can find any unsolved edge on the top face, move it in, and then slice back. Next up, let's try to do these 2 edges. We see that these are already adjacent to each other, but no slice moves can bring them together. Well, we can bring one up, back up to the top face, and then remember to insert it back, but into the top slot. And how do we do that? Well, not the same way, but we can do it from the other side. And here, when we insert this piece in, we'll have it inserted to the top slot. So now we can slice to pair them up, find an unsolved edge to replace, slice back. Lastly, how about let's try the blue and white edge. So we already have one here. We're gonna place this one in, slice, find an unsolved edge, and back down. So after you've done 4 edge pairings, you'll probably see that the top face is pretty much all paired up, right? We don't have any more unsolved edges here. Well, fairly simple. We can either flip the cube upside down, or we can just turn all of the solved edges to the bottom face. And boom, now your bottom is solved. So we can now continue on with this process. Let's try to do these 2 edges. Remember what we did? Well, we took one of these out. And then remember that now we need it to be at this spot. So we're going to insert this to the bottom like so. And then we can pair these two up, find an unsolved edge, and slice. Let's try to do these two. We have to get this piece to this spot, so we can do that like so. Pair these two up, in, slice. Let's try to do these two edges. We can move one of these out. We need this edge to be in this spot, so we have to insert that. And then we can slice, insert, slice. Now we have a pair that's already been paired. These two, we can slice these and put this one in as well. So now we reach the case of, well, all of the edges in the top face and the bottom face are paired up, but I still have a lot of edges that are not paired up in the middle. What do? Well, we can simply put one of these to the top, and now we have one unsolved edge to replace. So this edge is the unsolved edge, and for example, we see that, let's try to pair up these two edges. So pair these up, put the unsolved edge in, and back down. Now we see that we still have 3 edges to go, so we can move one of these up, right? And then let's try to pair up these two. Slice it, insert the unsolved edge, and back down. And now you'll run into one of two cases. Either these two edges are already solved, or you'll run into a case like this, or a case like that. No matter how you try to pair these up, there's just no unsolved edge to pair it into. For example, if you try to replace this edge with that, then you'll see that when you slice back, these two edges will be not paired up anymore. So what we have to do is do this algorithm, which is called the edge flip algorithm, right here. So let's try to flip this edge. And the goal here is to get the same edge to be both on the top, or the same edge to be on both on the bottom. And now what we're going to do is we're going to slice to the right. And then we're going to flip this edge over so that when we slice back, this edge will be paired with here. And then this edge will go here, and that will be paired over here. So do the edge flip algorithm again. And now we can slice back, and you'll see that these edges are solved. So now we reduced the 4x4 into a 3x3, and now we can just solve that with 3x3 rules. So of course, the cross, as a beginner, you would use the beginner's method, but I'll just finish F2L like so. There is a chance on the 4x4 that you might find something like that. And this case is just not possible on the 3x3. You have the first 2 layers solved, or in this case, first 3 technically. But you have one of these edges flipped, or an unrecognized OLL case. So this is what we call an OLL parity. Because the fact that we manually paired up each of these edges, there is a chance for one of these edges to get flipped, like so. So let's follow the OLL parity algorithm here. And now you see we just flipped this edge backwards. Now we have an OLL that is recognizable, and then boom. Now we see a PLL that is unrecognizable. Of course, there's the PLL parity with the 4x4 as well. You see this looks like a J-perm, but not really with headlights. So the PLL parity essentially flips this edge with this edge, and that's not possible on the 3x3. So the PLL parity goes like this. We're gonna put the ring finger here, and we're gonna flick up. Now we see that we have a recognized case for PLL and we can just solve the cube like so. So there you have it. That's how you solve the 4x4 Rubik's Cube. And if you have any questions, please comment down below. Thank you guys for watching, and I'll see you guys in the next video. Bye.